Welcome. This channel presents an alt anthropology perspective, raising questions about human origins that the mainstream media often ignores. This particular video marks a shift from our usual content, offering a more in-depth tutorial format. Over the coming months, we will be taking a deep dive into various hominid species. These include Homo erectus, Homo habilis, the Australopithecines, and most especially Neanderthals and Denisovans. To fully understand their place on the phylogenetic chart, it is crucial to grasp the key concepts of spatial and temporal dimensions. By examining how these species evolved and spread over time and space, we can gain deeper insights into our human origins. Definition. Note, you will often see spatio-temporal or spatial-temporal with a hyphen and simply spatial-temporal. All are fine. There really is no agreed upon standard. Spatio-temporal analysis involves examining the geographical distribution, spatial, and the chronological timeline, temporal, of hominid species. This approach helps scientists understand evolutionary patterns, migrations, and interactions over time and space. Temporal. In paleoanthropology specifically, temporal resolution refers to the precision of dating methods used to determine the age of fossil remains and their placement in a chronological context. For example, Homo habilis, one of the earliest members of the genus Homo, lived approximately 2.4 to 1.4 million years ago, whereas Homo erectus by some measures existed from about 1.9 million to 110,000 years ago. That is 500,000 years of overlap. So is Homo habilis ancestral to Homo erectus, or did erectus evolve separately from another hominid species? As we shall soon see, such questions are particularly vital to anyone studying modern human racial variation, especially those within the race realism and Eurotrad communities. Spatial. In paleoanthropology, spatial refers to the geographical range of a particular hominid species. Spatial understanding helps us map the geographical distribution of these species. Homo ergaster, for instance, has a spatial range on the African continent. Homo erectus is known to have spread across Asia, Melanesia, and parts of Europe. Yet, many paleoanthropologists insist on applying the Homo erectus taxa label to the African species. Chinese and Russian paleoanthropologists have been saying for decades that there is no relation between Eurasian erectus and African ergaster. This is likely a case of anthropologists in academia engaging in political sensitivities by using the label Homo erectus for African Homo ergaster, despite them being clearly two different species. Australopithecus africanus. Raymond Dart discovered the first Australopithecus africanus, the Tong child, in South Africa in 1925. His friend Dr. Robert Broom discovered an adult Australopithecus africanus 12 years later. Lucy, Australopithecus afarensis, was discovered in the Afar region of Ethiopia in 1974 by Donald Johansen and his crew. Johansen, Tim White, et al. Made the case that Australopithecus africanus came later and was a descendant of Lucy. Smithsonian. Australopithecus africanus was anatomically similar to Australopithecus afarensis with a combination of human-like and ape-like features. Compared to Australopithecus afarensis, Australopithecus africanus had a rounder cranium, housing a larger brain and smaller teeth. For decades, the phylogenetic charts illustrated the progression from Australopithecus afarensis to Australopithecus africanus. This sequence was prominently featured in biology textbooks. In 2022, new evidence emerged that stunned the paleoanthropology world. Redating specimens of Australopithecus may rewrite human history, headline The Economist. Purdue University.edu 2022. Geologist Daryl Granger just pushed the age of some of these fossils found at the site at Sterkfontein Caves back more than 1 million years. This would make them older than Lucy, the world's most famous Australopithecus fossil. For decades, Johansen fervently argued that Lucy stood at the base of the human family tree, directly leading to the first species in the genus Homo, Homo habilis. Time, 1987. Donald Johansen thinks that a single species, Australopithecus afarensis, which includes Lucy, is the common ancestor. Continuing, Richard Leakey believes the common ancestor is an older species which is yet to be found. Note aside, Leakey's wife Maeve years later discovered Kenyanthropus platyops. Initially, Australopithecus africanus was believed to be younger than Australopithecus afarensis. However, advanced dating methods in later years disproved this assumption. The comparison between Australopithecus afarensis and Australopithecus africanus underscores the significance of precise temporal spatial analysis. Homo erectus versus Homo ergaster. Wellesley College anthropology professor Adam van Arsdale. Homo erectus is often referred to as the first cosmopolitan hominid lineage, meaning the first hominid species whose geographic range had expanded beyond a single continental region. Continuing, while fossil remains from Homo erectus are found in Africa, they have also been identified at fossil sites widely dispersed across Eurasia. The species was not only geographically widespread, it also had a long temporal span in the hominid fossil record. Professor Van Arsdale was a longtime analyst at the Denisovans site in Georgia, where 5 Homo erectus crania were found in the 1990s. The site and the fossil specimens discovered there have sparked significant controversy over the years. The temporal span of Homo erectus is estimated to range from approximately 2.2 million years ago, based on recent lithic finds in China, to 107,000 years ago from Java. Is Homo erectus truly a single species, or do the Asian specimens represent Homo erectus while African fossils from the same period signify an entirely separate species? Earlier paleoanthropologists like Ralph von Koningswald, Franz Weidenreich, and the renowned Eugene Dubois debated whether Dubois' Java specimen should be classified as Homo erectus, similar to the Peking man Zhou fossils. Eugene Dubois famously became enraged upon discovering that von Kay and Weidenreich intended to classify his Pithecanthropus fossils under Homo erectus. Dubois staunchly believed they represented a distinct species, Java man. The Leakeys aimed for a straightforward evolutionary progression from Homo habilis to Homo erectus. Consequently, they initially categorized several African specimens under the Homo erectus taxa. This would place their beloved Homo habilis at the base of genus Homo, forever enshrining the Leakey family name as the discoverers of our human species. But some paleoanthropologists, such as Colin Groves and Bernard Wood, question the lumping of the Asian species with the African, based on examination of a suite of morphological features, including the mandible, dentition, and cranium size. Australia Museum. Features that had initially been thought to be early forms of Homo erectus from Africa. All these fossils have now been reclassified as Homo ergaster. And complications emerged with lumping Homo erectus and Homo ergaster together from a temporal standpoint. Susan Anton, paper, Natural History of Homo erectus. The species, broadly interpreted, appears to expand quickly into its entire range, but to disappear at least a half a million years earlier in Africa than in Asia. As we have suggested in previous videos, the distinct spatial temporal patterns of Homo ergaster and Homo erectus could indicate species divergence among modern extant Africans and Europeans. Homo naledi. When Homo naledi was first discovered in 2013, Berger made an initial guess based on soil sediments, estimating that the species could be as old as 1.8 million years. Most paleoanthropologists initially classified the species as an Australopithecine, considering its morphology, stature, cranium size, and Berger's preliminary dating of 1.8 million years. In 2017, the dating of the surrounding geology was completed, and the results shocked scientists. Homo naledi was dated to be between 236,000 and 335,000 years old. This meant, despite Homo naledi's Australopithecine-like cranial capacity of 470 to 600 cc, the species was correctly designated as genus Homo. With Homo naledi, scientists initially made their taxonomic designations based on an incorrect temporal estimate of 1.8 million years. It later turned out that the species was only around 300,000 years old. Denisovans, Homo longi, and Melanesia branch. Denisovans were first discovered by Russian scientists in southern Siberia in 2008. Genome sequenced by scientists at the Max Planck Institute. In the early days of discovering Denisovans, researchers did not fully grasp the spatial range of the species. Now, over a decade later, evidence suggests that Denisovans may represent multiple species. The spatial map for Denisovans runs in a north-south axis from the Altai Mountains in Siberia to the islands of Indonesia and Papua New Guinea. Given the vast spatial ranges from Siberian tundra to high mountain ranges and tropical jungles, even the most hardened monospecies proponents would be hard-pressed to argue that Denisovans represent a single hominid species. Additionally, recent genomic data and new fossil discoveries such as Homo longi in northern China bolster the argument that Denisovans might actually represent multiple species. Professor Murray Cox from Auckland University in New Zealand has identified genetic markers of Denisovans in Papuan populations, revealing that D2 Denisovans are as genetically distant from Altai Denisovans as they are from Neanderthals. Paper 2024. The evidence suggests that several Denisovan populations who likely had an extensive geographical range were adapted to distinct environments and introgressed into modern humans multiple times. And as Professor Cox of New Zealand has suggested, those distinct Denisovan populations could indeed be entirely different species. Introgression from various archaic hominid species could account for the extensive morphological diversity observed among Melanesians and Pacific Islanders. This is especially true for Papuans, as geneticists have discovered mysterious markers in their genome, including super-archaic, possibly Homo erectus. The Neanderthal Enigma. As we will see in future videos in this series, getting the spatial-temporal right is critical in our understanding of Neanderthal subspecies. The spatial range of Neanderthals runs from the tip of Gibraltar to the Altai Mountains in Siberia. In brief, there are Western branch Neanderthals, Vindija, Mezmatskaya, Chagarskaya, and Altai. Europeans have 1.8 to 2.4% Neanderthal DNA admixture. The majority of the DNA comes from the Vindija and Mezmatskaya branches. For those who are European heritage enthusiasts and others who study genetics, haplogroups, and human racial differences, the Vindija branch may hold the greatest significance. While it might be natural to assume that Neanderthal DNA admixture in present-day Europoids comes from the Western classical branch, in actuality, a significant percentage of that DNA comes from the much later surviving Vindija. Vindija and Mezmatskaya branched off from each other 60 to 80,000 years ago. The Chagarskaya branch is more closely related to Mezmatskaya, despite being spatially closer to the Altai. The Altai Neanderthals are an extremely archaic branch, having diverged from other Neanderthals 140,000 years ago. They are more closely related to the classical or Western Neanderthals. And there might be yet another mysterious unknown branch in the Altai. Paper 2022 Genomic Analysis of a Novel Neanderthal from Mezmatskaya. The Denisovan and Neanderthal hybrid revealed that she shares more alleles with the late European Neanderthal than with the Altai. More to come on Denny and the lost tribe of Neanderthals. New discovery in the mountains of France. A groundbreaking fossil find in southern France has revealed a new Neanderthal subspecies, shaking up the phylogenetic and chronological narrative of Neanderthals. Join us in the upcoming series as we explore the work of French archaeologist Ludovic Slimak and his discovery of Thorin. Thank you for watching. Make sure to subscribe, hit the like button, and leave a comment. We'll see you soon.